marveled at the mysterious attraction between two balloons when someone blows them up in close proximity.
It's like they have a secret dance choreographed by Bernoulli's principle.
Join us as we unravel the secrets behind the physics in our everyday lives.
So let's start with the Bernoulli's principle model, which explains how the pressure within the fluid decreases as its speed increases and vice versa, as long as the flow is steady and the fluid is incompressible. It's commonly applied in various fields including aerodynamics, where it explains how aircraft wings generate lift.
Wait, Maryjoy, ano nagbarog din na?
I'm thinking about standing wave model. Have you ever wondered this? The standing wave model describes a phenomenon where waves appear to be standing in place rather than moving forward. The standing wave model can be applied in telecommunications and physics education for optimizing designs, demonstrating wave properties and understanding resonance. Uy, ano nag-wave ba sa dito?
Ay, namasundin yung wave good. Mechanical wave naman good eh. So, mechanical waves are disturbances that propagate through a medium, transferring energy without permanently displacing the medium. So these are two mechanical waves, the longitudinal wave and the transverse wave. Other examples for mechanical waves are sound waves, water waves, and seismic waves.
Ay, wanna balance? Static equilibrium explains the condition or where an object remains stationary or moves at a constant velocity due to the forces acting upon it. Factors involved include magnitude and directions of all forces and moments acting on the object.
Liquid pressure models help engineers design and maintain plumbing systems in buildings to ensure consistent water pressure and prevent pipe leaks or bursts.
Doppler effect model explains how the pitch or the frequency changes when the source of the listener is moving. Factors affecting this model include the relative velocity between the source and the listener, as well as the sound speed in the medium.
As the car moves away from the listener, the perceived sound gradually decreases over time. This change in perceived sound or pitch is a result of the change in frequency of the sound wave caused by the relative velocity between the car and the listener. So, the faster the car moves away, the greater the decrease in perceived sound frequency.
Application of Doppler effect includes police radar to measure car speed, as well as in the medical field, it is used for medical ultrasonic for imaging blood flow.
Gravitational potential energy model describes the energy stored in an object due to its position in a gravitational field. Factors involved include the mass of the object, the acceleration due to its gravity, and the height above a reference point. Applications involve understanding the energy transformation in objects lifted or lowered in gravitational field, calculating the energy required for tasks like lifting weights and raising water in and down.
Hala, nanapuligi kay bagong car. Siyempre, bigway. Mo ang Pascal's model. Pascal's principle model, or the Pascal principle, states that the pressure being applied to a confined fluid is transmitted and diminished to all directions. Factors include the pressure applied to the liquid as well as the area where it is applied.
Pressing on one end of a hydraulic system results the uniform transmission of pressure throughout the container, causing the fluid to distribute the pressure equally to all parts of the system. This uniform pressure distribution is why the car is elevated in this hydraulic system model.
Periodic motion or simple harmonic motion or SHM is a type of motion where an object repeats its path over a fixed interval of time, typically following a sinusoidal pattern. Factors involved in SHM includes the object's mass, the force acting upon it, and its displacement from the equilibrium position.
The buoyancy model elucidates how objects immersed in fluid experience an upward force equal to the weight of the displaced fluid, known as buoyant force, which allows them to float or sink. Factors involved include the density of the object and the fluid, as well as the volume submerged. This model finds applications in designing ships and submarines, understanding the behavior of floating objects, and determining the stability of underwater structures. When you squeeze the bottle, you increase the pressure inside. This compresses the air in the dropper, causing it to sink due to increased density compared to the surrounding water. When you release the pressure, the air expands, decreasing the density and causing the dropper to rise. This demonstrates how changes in pressure affect buoyancy, as explained by Archimedes' principle.
Freefall and projectile. Freefall refers to the motion of an object under the sole influence of gravity, experiencing acceleration downward with no other forces acting upon it. Factors involved in freefall include the initial velocity, gravitational acceleration, and air resistance if applicable.
Kepler's model describes the motion of celestial bodies, particularly in planets in elliptical orbit around the Sun, governed by three laws. Factors involved include the masses of celestial bodies, their distance from each other, and the gravitational force between them. Applications include predicting planetary position for astronomical observation, spacecraft trajectory calculations for space missions, and understanding the dynamic of star systems.
The angular momentum models explains the rotational motion of objects and systems in terms of their mass, velocity, and distance from a central axis. Factors involved include the object's moment of inertia, angular velocity, and any external torques acting upon it. Step into the world of everyday physics with us. That's all for this video. I hope you learned a lot. Thank you.